Hi guys, this is lesson one, or I'm sorry, lesson two of topic one. We are going to make sure you know what irrational numbers are. I'm going to go over three examples with you. I will not do this all the time, but since this is the beginning of the school year and everybody's getting used to this, I will keep my face here on the screen for you so you understand what to do. So watch this as I play it. I'll help you out with it. You will have example one, example two, and example three to do on yours, on your class for classwork, and you also have practice and problem solving. I'm going to go over each of those a little bit and tell you some of the tricks and things that you need to know. So here's what we are actually wanting to know.
How is an irrational number different from a rational number?
Okay, please recall that we talked about rational numbers whenever we did lesson one. A rational number is anything that can be written as a fraction, and we changed a repeating decimal into a fraction. So the connection to that is repeating decimals are rational numbers because we were able of changing them into a fraction. An irrational number, we didn't talk about it yet. So we want to know what in the world is an irrational number. Let's distinguish between the two.
Think about this question during the lesson. The Venn diagram shows the relationships among rational numbers. A number that can be expressed as an integer or a ratio of two integers is a rational number. When expressed as a decimal, the decimal is either terminating or repeating.
Okay, there's the connection to lesson one, guys. Whenever we did repeating decimals, we were able to turn them into a fraction, which made them rational numbers. They are rational numbers we could write as a fraction. So here you have a fraction. Here you have a terminating decimal. If we wrote a repeating decimal here, obviously that would still be rational.
An integer is a positive or negative whole number.
Okay, so here's integers. Now, we say that they're positive or negative whole numbers, and I know I may have explained that to you in class. And what's really weird about this is they put 16 over 4 here to try to fool you. Even though it's written as a fraction, please remember all year in math you will learn to simplify everything. 16 divided by 4 is equal to 4, therefore it is just a whole number, therefore it is an integer.
Or zero. Whole numbers are the positive integers and zero.
Okay, so your whole numbers here, notice they try to kind of throw you a little curveball again. The number 6 is written as a decimal 6.0, but it is still 6. The number 13 is written as 13 over 1, which is a fraction. So simplified, it is again the number 13. Therefore, it's a whole number. Whole numbers are not permitted to be decimals or fractions unless they simplify to a whole number.
Whole numbers have no fractional or decimal parts, and they do not include negative numbers. A natural number is a positive integer greater than 0.
Natural numbers, you may remember those as the counting numbers. So when you start to count, you start as 1, 2, 3, 4. Those are all your natural numbers. The only difference from a natural number and a whole number is that a whole number includes the number 0. Some mathematicians say that natural numbers have 0 in them as well. So there's a little bit of a discrepancy between who your teacher is and what standards they want you to know. So don't panic if you say, hey, 0 is a natural number. In our case, we're not learning it is to be, but in other mathematicians' case, it may be.
Negative numbers and fractions are not natural numbers. How would you classify the number 0.247583326 and so on? How can you use the definition of each number set to classify numbers? Is it a natural number? No. Decimals aren't natural numbers. The same is true of whole numbers and integers in general. Then maybe it is a rational number. Is the decimal a terminating decimal? How do you know?
So notice in this case, guys, that this decimal is not repeating. It's non-repeating. And these 3 dots indicate that it's non-terminating. That means it will go on forever. These are the indicators right here, these 3 dots, that something is non-terminating, which makes it an irrational number. We actually can't make it a fraction, so we really don't know what it is because it actually goes on forever and ever and ever.
The number is not a terminating decimal. The 3 dots at the end tell us that the decimal goes on forever. We don't know what they are, maybe 5, 8, 3. But we do know that they are not repeating, nor are they all 0. So, is the given number a rational number? It can't be. The decimal is neither terminating nor repeating. Numbers that are not rational are called irrational. An irrational number is a number that cannot be written in the form a divided by b, where a and b are integers and b is not 0. The number 0.247583326, and so on, is irrational because the decimal expansion is non-repeating and non-terminating. Irrational numbers include non-repeating decimals, most positive and negative square roots and other roots, and special numbers such as pi.
So here we see, guys, square roots. This is the square root of 2. The square root of 2 is irrational because it is not a perfect square. You see negative square root of 3. It is also irrational because it is not a perfect square. The fact that it is negative really doesn't matter. We're looking at the square root of 3 as not being perfect. Pi is another number that will continue on forever and ever. It will never stop. If you put it on your calculator and you push the pi button will tell you 3.145693, and it will keep going and going and going and going on and on forever. So it is a special symbol that we know that is irrational. However, pi, we use the number 3.14 for pi. This number here, it appears as though it is repeating, but it is not. So be very careful with X. They're going to try to trick you with that in this lesson. So you have 1, 2, 1, 1, 2, 1, 1, 1, 2. So it's not actually repeating because of those different numbers that are in there.
Suppose the decimal was written as 0.247583326. Would this decimal be a rational number?
In this case, this decimal would be a rational number because it stops, it terminates. It does not have those three periods at the end of it. So they try to fool you like that a little bit. So just be careful of that. Like I said, the indicator is the 3 dots. The 3 dots tells you that it goes on forever without stopping.
Now the decimal terminates, so it would be a rational number. It's 24,758,326 10/100 millionths. Now you know how the different types of numbers are related and how to classify them.
Now, this is not the only part of example 1 that you have to do. Remember that there's always a second page. So if you look over here, it says 1 of 2. So if I'm going to click to page 2, when I go to page 2, it's asking me to first classify each as rational or irrational. And then secondly, it says Jen classifies the number 4.576 as irrational because it does not repeat. Is she correct? And explain it. So what I tried to do was I tried to grab these and drag them into here, but I can't do it. It won't pull those in there. So what you'll have to do is create yourself a text box. And you may move that text box around if you like. I'm going to just type in rational numbers. And I'm going to hit enter. And I'm going to type in the rational numbers that they gave us. And I don't know why I can't move this around. You may have to move that around, but when you type rational numbers in here, like one of them is -17, one of them is these ones up here, these are all irrational, so these would be my 3 irrational because of the terminating decimal. So you're going to have to make a box for rational numbers, a box for irrational numbers. Then you may also have to create, like here we can move rational numbers over here, and I also know that negative or 0.76 repeating is rational, and 3.275 is rational because it is terminating, it stops. Oops. 3.275. So I can just, since I can't drag them in there, I'm just going to create that. Click out of it, and then you have your box here. Create another box for irrational numbers. In order to type pi, you can't really type that symbol, so just write pi, P-I. Over here where it says construct an argument, in your text box, you could type in your text box that the number 4.567 is rational because it is a terminating decimal, which means it stops. So make sure you're using terminating decimal so you increase your vocabulary. And then again, if you click outside of that, is the only way that you're able to move it. I had a little bit of trouble with that. So here you go. Put it right there and you're done with example 1.